Yeah. So law of conservation of energy. What was it? You said it is energy cannot be created or destroyed. What else? Except it changes from one form to another form. Okay. And this same law goes by different names in chemistry. So for example, when you're talking about covalent substances, we take this thing and we name it He's cycle or He's law. And there's a little bit of some modification for covalent substances, but overall, the idea is the same, that energy is not created nor destroyed in a chemical reaction. It's just changing from one form to another, from bond energy to thermal energy, kinetic energy of particles. Similarly, in ionic compounds, we use a different name for it. We call it a bond-Haber cycle. But again, that's still the same idea, that energy is not created or destroyed. When an ionic compound is made, it's just going to change its forms. It's just going to store or being released. And all of that comes together to give us how an ionic compound is formed. So there are three things that we're going to talk about in this chapter. First one being what lattices are, how they're formed. Second, how ionic solids are made and what happens when you dissolve them. And third, this law of conservation. Okay. So it's not that tough, honestly. So let me just introduce you to the idea of lattice energy. Any idea what that is? Now, we use the term lattice enthalpy or lattice energy interchangeably. There is a very small minor difference in them, but we don't need to look into that in A2. So the idea is that lattice energy or lattice enthalpy is the energy that is given out. That's the first thing, energy given out. Okay. When 1 mole of an ionic substances or ionic solid is made, 1 mole ionic solid is made. So obviously it is an ionic solid, which means it will be a lattice from free gaseous ions. So one way to look at this would be that you have these ions. So for example, let's take a simple substance like sodium chloride. So the ions that make it are going to be sodium ions and chloride ions. So let's say I have sodium ions, they're the yellow ones, let me call that. And I have chloride ions, let me call those this. And now they're all going to come close together and they're going to form this lattice, okay? And in the lattice, you're going to have sodium ions surrounded by chloride ions, okay? Of course, that's not exactly how they're formed, but they basically come close together and they form this. So the black arrows, if you look at this, the green arrows over here, they're telling us that they're coming together. And these ions, they come close together, they join this lattice, and this lattice is a crystal lattice, the same thing that you have been seeing from O levels. And they arrange themselves in an orderly fashion. And in doing that, obviously, they're going to form energy, form bonds. And whenever a bond is formed, if you remember from grade 10, energy is released when bonds are formed, right? So they are forming these bonds. This bond is obviously the ionic bond that you have. So it's an ionic solid that is being made. But these are free ions. They did not have any bonds in between each other. They were just ions. So over here, we take away from the idea of ionic bond. We're basically saying that lattice energy is the energy released when ionic bond is made. Literally, that's all we are saying. So whenever an ionic bond is made, obviously it leads to a crystal lattice being made. So we have ions, they form the lattice, that's the ionic bond process. Okay, and the energy for that, we call it a lattice energy. So it's a really simple thing. So let me write the equation. So we can either draw it or we can write the equation for this. So for sodium chloride, the lattice energy is going to be, you take the ion that forms this and you bring them close to each other and they form sodium chloride solid. So they're gaseous before this happens and they form the sodium chloride solid. Now here's the thing. There's a lot of history behind it. The history of this chloride ion is that it was chlorine molecule that changed to chlorine atom that then gained an electron. So there are 3 steps that it has already been through before it got to this stage. And this sodium ion also has a history. What do you think its history is? What has this been through? So how does sodium exist in nature? You can unmute yourself and you can answer. Yeah, so sodium over here, it has been through, it was sodium solid, then it changed to sodium gas. Every atom liberated itself from the metallic bonds that were there. And then they lost the extra electrons that they had, the valence electron that they had. So those are again 3 stages that this sodium, 2 stages that the sodium has been through. And together, they're coming together and they're forming this sodium chloride solid. And the energy in this process, the delta H of this process, that is what we'll call lattice energy. Okay, so I'm writing it as LE. Now, there are 3 things that I said. Lattice energy is the energy given out when 1 mole of the solid lattice is made from ions. And we're going to add one more thing here under standard conditions. And that will be the standard lattice energy. Okay, so now we have 4 things. The 3 things for lattice energy were energy given out when 1 mole solid was made from gaseous ions. So these are the 3 things. And then the 4th one is under standard condition. If that happens, then that will be the standard enthalpy for this. And interestingly, it is always exothermic. And it is always exothermic because just adding on to the ideas that we already have from grade 10, that energy is released when bonds are made. So because it's always bonds being made, ionic bond, it's always going to be negative. Okay, so that's the enthalpy or the lattice energy that we have. Now, what does it depend on and why is it important? In a way, lattice energy tells us the strength of the ionic bond that you have, because it's always the energy is released through the bond. So obviously stronger bonds, higher energy, that's all. So that means we can measure lattice energy and take that as a measurement for the strength of the ionic bond. So there are so many positive and negative ions, they're coming together, they're forming this lattice, all of that. And the stronger the bond that they make, the higher the energy that they release. And that is how we know that this force of attraction between ions, if it is strong, then the lattice energy will be high. So what is lattice energy? A measure of the force of attraction between ions. And how does the force change? That's what we are going to talk about. Because if you change the force of attraction, you change the value of the lattice energy. Okay, so that's what you have to understand, that what does the force depend on? Now, this force is between positive and negative ions. So obviously, if the positive ions have a greater charge and the negative ions have a greater charge, they will attract each other more. And more than that, it's also about the distance between them. If the cation and anion are closer together, they're going to have obviously greater force of attraction. And if they're further away, they're going to have weaker force of attraction. Now, if you take physics, then there's a law in there which is called Coulombs Law. The Coulombs Law basically tells us how 2 charges attract each other. So it says that force is directly proportional to the charges on 2 things divided by the distances between the 2 things. In chemistry, we're going to take the same thing because the force of attraction between ions is what we're talking about. And the ions are the positive and the negative charge that we have. So the charge, if it is higher, the force is higher. And the R over here is the distance between them. And we will take that to be the ionic radius or ionic radii, because we're talking about 2 radii, 2 ions. So we'll add the radii together. And these are the charges on ions. And together, we have one way of explaining what this is. We say that that is charge density. Charge density is basically how much charge any ion has and how that charge is distributed in the cloud of electrons that that ion has, the whole size of the ion. Okay, so together they're going to tell us how the force of attraction between ions changes. And if you know force of attraction, how it changes, you know lattice energy. The stronger force, the higher the lattice energy. Okay, now that we know the ionic radius, we know that charges affect the force of attraction, and that force of attraction affects lattice energy. Let's look at how this changes in the periodic table. So, for example, for positive ions, we know that down the group, the ions are going to become bigger and bigger and bigger. So that means the distances are going to be higher. But if you're talking about the same group, the charge stays the same. So charge stays the same, but the size increases. So this is the constant, but this is increasing, which means force will decrease. And that brings us to the first main trend that we have, that down the group, lattice enthalpy goes down. And why is that? That is because charge density decreases. The same charge is distributed on the greater size of the ions. Okay, so there you go. If you increase the charge density increases. If you decrease the radius, charge density increases. So two ways you can increase the charge density. So that means in group 1, group 2, and group 3, you can clearly see that the charge is going to increase and the size is going to decrease, because across a period, the size decreases, but the charge increases. And I'm talking about the same ion, by the way. So if you have just the positive ion, so group 1, group 2, group 3, or 13, the size of the ion in the same period is going to decrease. And you already know why that is. That is because of greater effective nuclear charge, and it all comes from AS chapter 1 or 2. So across a period, lattice energy increases for same kind of charge. So if you have just the cation, then across a period it's going to get smaller and smaller and smaller, which means you're going to get greater charge density, greater lattice enthalpy because of that. Similarly, if you talk about the negative ions, then starting from group 4 or 14, moving on to group 7 or 17, you can clearly see that the charge density will vary based on two things. The charge will start to decrease because group 4 will have a -4 charge, group 5 will -3, group 6 -2. So charge is going to decrease, but at the same time, the size is also going to decrease. So that is why for anions, it becomes a little tricky. Okay, but for cations, the idea is simple. Across a period, the charge is going to increase, the size is going to decrease, lattice enthalpy will be higher because charge density is higher. So for example, let's say I want to compare NAF and CAF2. Which one do you think will have a higher lattice enthalpy? For that to be compared, you need to make sure कि कुछ तो same होना चाहिए उनमें. So over here, fluorine is same for both of them, which gives us something constant so that you can focus on sodium and calcium. The comparison will be between their charge densities and how that affects the lattice enthalpy, because fluorine's contribution is roughly the same. So clearly you can see that if you break these down, sodium is +1 and calcium is +2. So clearly calcium has a bigger charge. But at the same time, calcium is also a bigger ion. So that makes the comparison a little tough. And we will need to go into calculation of this. But the general idea is that if I were to change calcium, and let's say I had magnesium here, now I can easily compare them. I can clearly see that sodium and magnesium are in the same group, which means magnesium is smaller, has a higher charge density, greater lattice enthalpy. Now let me compare sodium fluoride with sodium chloride or sodium bromide. So how does their lattice enthalpy change? Clearly, they're the same positive charge, but same negative charge, but the charge is being distributed on a bigger ion now. Negative ion बढ़ गया ना? So that means fluoride छोटा है, chloride उससे बड़ा है, bromide उससे भी बड़ा है. And because of this greater charge, we can clearly see that the values will start to go down. And that's exactly what we expect, and that's exactly what happens. The lattice enthalpy decreases. Okay, so basically the idea is you just focus on what affects the force. अगर force of attraction ज़्यादा हो रही है, lattice enthalpy ज़्यादा हो रही है, because lattice enthalpy कुछ भी नहीं है, just a measure of how strong the forces are. Okay? All right, so time for a quick break. Tell me the definition of lattice enthalpy, and then write the equation for lattice enthalpy of magnesium fluoride. Go on. So write down the definition of lattice enthalpy and the equation for magnesium fluoride lattice enthalpy. Take a minute. Okay, so here's what I would expect you to be able to do. First of all, explaining or defining the term lattice enthalpy, you must include three things, which are, it is the energy released, that's one. Second, when gaseous ions, that's two, come together to form an ionic lattice. The lattice word is the third important thing, or ionic solid. So these three things, if you mention that, that's lattice enthalpy or lattice energy. I did not say standard, but if the examiner asks you for standard, just add the word in standard conditions. For magnesium fluoride, lattice enthalpy is going to be, you take this, and magnesium ions, you need those ions in gaseous state. Fluoride ions, you need them in gaseous state. You obviously need two of this. It will form 1 mole of magnesium fluoride. And that is what the definition was as well, that 1 mole of an ionic solid is made from free gaseous ions under standard conditions, and the energy released in that is lattice enthalpy. Okay, so that's the thing. Now, question number 3. Describe and explain. So in the exam, examiner wants us to describe and explain means that they want us to tell how something is and also tell why it is the way it is. So describe का मतलब है कि how, जो बस बता दो कि क्या है वो. And explain means कि उसकी reason भी बताओ. So describe and explain why the lattice enthalpy of magnesium fluoride, the same thing, will be different from calcium chloride. Now the examiner has not asked us कि बताओ कि कहाँ से आती है, क्या आती है, ये वो सारा. You're going to talk about the ions in there. You're going to talk about the charge density in there, and that's how you should be able to describe it. So because it's just your first question, so I'll explain. The first thing to do would be to break it down into the ions. So 2 plus minus 1, 2 plus minus 1. So clearly you can compare them with the same charges. But if you look at it, calcium chloride is in the group, same group, calcium is in the same group as magnesium, and chloride is in the same group as fluoride because of the charges. But chloride is bigger than fluoride and calcium is bigger than magnesium. So you have, what do you have in common? You have same charges. You have bigger size. So same charge, bigger size leads to greater charge density in magnesium fluoride. So because magnesium fluoride has greater charge density, it will obviously have stronger lattice enthalpy. So now that you have thought through this, when you talk about describe part, you will say magnesium fluoride has higher lattice enthalpy. You don't need to give any values because you don't have any values. Describe wala part ho gaya. You have told me how it is. It's going to be higher than calcium chloride's lattice enthalpy. अब अगली बात आप इसकी reasons पे आओगे. So you'll talk about how it has the same charges, but the sizes of calcium fluoride or calcium chloride ions or calcium ions and chloride ions are bigger. In fact, it would be a better thing to do. अगर आप बोलो कि calcium ions are bigger than magnesium ions, so they have lower charge density, and chloride ions are bigger than fluoride ions. They have a lower charge density, and because of that, the forces of attraction are going to be weaker compared to those in magnesium fluoride. So lattice enthalpy is going to be weaker. Okay. And sometimes instead of comparing two different compounds altogether, examiners sometimes क्या करते हैं कि वो आपको एक ion change करवाता है, which is again, for example, sodium fluoride and magnesium fluoride. That's a comparison for those. And that's it. That's what the examiner expects you to be able to answer. It is always lattice enthalpy के दो factors हैं, उनको explain करें और बताएं कि कैसे वो change होते हैं. Okay, so you will see the same question repeated multiple times throughout the same worksheet that I'll share with you after this class. और उसमें वही क्वेश्चन बार बार डिफरेंट कंपाउंड्स के लिए डिफरेंट तरह से वो पूछता रहेगा. एग्जामिनर के फेवरेट कंपाउंड्स कौन से हैं? सोडियम और मैग्नीशियम के ऑक्साइड्स या उनके हैलोजन कंपाउंड्स. वो आपको सोडियम मैग्नीशियम का कंपैरिजन करवाता है और ऑक्साइड दे देगा कि मैग्नीशियम ऑक्साइड और सोडियम ऑक्साइड को कंपेयर कर दो, मैग्नीशियम क्लोराइड और सोडियम क्लोराइड को कंपेयर कर दो. एक तो वो ये करेगा. दूसरा एग्जामिनर क्या करता है कि वो मैग्नीशियम और कैल्शियम आयंस के साथ आपको कंपेयर करता है, जैसे आपके सामने मैग्नीशियम फ्लोराइड और कैल्शियम क्लोराइड का आपस में कंपैरिजन करें. सो आई एम गोइंग टू आस्क यू टू स्पेंड 2 minutes on this and I'm going to ask you to write how. So again, describe, which means how, and explain how lattice enthalpy changes or lattice energy changes between, here are the two things, magnesium oxide and sodium oxide. That's the first one. Okay. And the second one I'm going to ask you for is magnesium fluoride and calcium chloride. So go on, take 2 minutes, write their answer. These both will be 3 marks each. Sorry, this one will be 2 marks if it comes in the exam. All right, so if you've written the answer for this, just make sure that in the first one, you need to be able to compare the two factors that change between sodium and magnesium. Your answer doesn't need to compare oxide because oxide is this constant thing in both of them. And we are going to talk about the changes. So the change is not coming from oxide. So it's coming from sodium and magnesium. So talk about how sodium is a bigger ion with lesser charge than magnesium, which has double the charge and smaller size. Don't say that the energy is going to be 2 times higher or anything. Don't give a number there because you don't have values. In the second question, you have to be able to compare magnesium with calcium and fluoride with chloride and talk about the factors that affect these two. Okay. So that's one part of what the examiner expects you to be able to answer. और जिसके ऊपर वो ज्यादा आपको क्वेश्चन देता है. दूसरी चीज जो एग्जामिनर इसके साथ रिलेट करता है, which isn't technically the same topic, but it does relate to it. It is the trends in ionization energies, how they change. So that is from your AS. But let me give you an example. Let's suppose यही calcium chloride वाला question होता. Examiner can easily relate this to telling you or asking you why the ionization energies change for the same ions. So for example, the first ionization energy of calcium in this case, and the second ionization energy of calcium in this case, they're going to obviously be different. In fact, second one is going to be higher. So examiner will expect you to be able to tell why that is, because you see, calcium ion is a +2 ion. So calcium पहले +1 होता है, फिर +2 होता है. So examiner will expect कि आप बताएं कि +1 होने में और +2 होने में कितनी एनर्जी का डिफरेंस आएगा और what factors affect those. So that is from AS, but let me just remind you of what it is. So there were 3 factors that affected the ionization energy. And they were all about how the force of attraction between the nucleus and the electron that is leaving that nucleus, how that changes. So again, it is all a manifestation of Coulombs law. वही Coulombs law हमेशा बार-बार आएगा जहां पे भी आप charges को affect करने की कोशिश करेंगे. So you have to talk about effective nuclear charge, which is a charge on one nucleus. in the Coulombs law, it's one of the two factors in numerator. Electron का तो charge same ही होगा. Then it's about the distance. So अगर आपका distance कम हो रहा है तो आपकी force of attraction ज़्यादा हो रही है, जिसकी मतलब ये होगा कि उसको break down करने के लिए energy भी ज़्यादा चाहिए. So हम बात करेंगे that how effective nuclear charge is higher once you have a +1 charge on the thing because the ion is smaller. Okay, so calcium atom and calcium +1 ion, the effective nuclear charge is higher in the +1 wala. And at the same time, is it smaller? Not really, because the shielding effect stays the same between calcium +1 and calcium atom. Shielding पे उतना फर्क नहीं आ रहा, तो उसका मतलब है कि distance पे भी उतना फर्क नहीं आ रहा. So the decisive factor is that calcium +1 will have greater effective nuclear charge than calcium atom, which means you will need more energy to remove an electron from this calcium +1 ion than just the calcium atom. So examiner इनको relate करता है और वो आपसे पूछता है. So lattice energy पे तीन तरह के question आएंगे. First question will be, they will ask you to define or write the equation for lattice energy. Second question will be that they will ask you to compare these different ions that you have. And they will ask you कि अच्छा इस वाले को उस वाले से compare करें या इस lattice को उस lattice से compare करें in terms of their energy and what factors affect it. And all of that comes from Coulombs law, which obviously builds up on the charge densities concept. And third question that they will ask you is its relation to AS. ठीक है? Because मैंने आपको साथ में past paper को कैसे practice करना है, कैसे attempt करना है, वो भी सिखाना है. So it's important that you know how many kinds of questions are going to be asked and how you can be able to answer those. All right. So that was the very simple concept that I wanted to discuss today. I would like you to revise energetics from AS, especially the solutions or how his cycle was, because tomorrow we'll talk about Born-Haber cycle and we'll talk about how the Born-Haber cycle comes into play and how it is a manifestation of the law of conservation of energy. Okay, so that was lattice energy. The second thing that I wanted to talk to you about today. Any question in lattice energy? I'll take that. So in case you don't have a question, that's okay. If you do get a question later on, feel free to WhatsApp. There's also a WhatsApp group, Rapid Revision A2. You can ask questions over there. It's a very helpful community. If you're not there, I'll just ask them to add you.